Imagine this. You're standing in front of a towering bridge, hundreds of meters long, suspended over a deep valley. It's majestic, solid, unmoving. A tourist beside you mutters, "Wow, I wonder which architect designed this masterpiece." You smile politely, but deep down, something stings. Because you know the truth. This wasn't just designed, it was engineered. And not just by anyone, but by a structural engineer. Yet, in many people's minds, our work is often misunderstood, overlooked, or even invisible. Today, as your structural engineering professor, I'm here to bust the top 5 myths about what we really do. Let's set the record straight, once and for all. This is perhaps the most common and most misleading myth. Sure, architects create the vision, the form, the beauty, but it's the structural engineer who makes sure that vision won't collapse on a windy day. Let me tell you a story. A few years ago, an architect brought us a design for a large cantilevered balcony, 6 meters off a cliff. It was stunning. The client was impressed. The architect was proud. But gravity? Gravity was not impressed. Our job wasn't to say no. Our job was to make it possible safely. So we introduced post-tension beams, redesigned the moment connections, and even added hidden tension rods. The final design looked exactly like the original, but this time it wouldn't fall into the valley below. Architects dream. Engineers deliver. It's a partnership, not a hierarchy. Yes, math is our language. But structural engineering is also about intuition, creativity, and judgment. Think of it this way. You can calculate the bending moment in a beam, but knowing where the failure might start and why requires experience and imagination. I once asked a student, "Can this beam fail?" They replied confidently, "No, professor. The equation says it's safe." But they hadn't noticed a small eccentric load placed just off-center. The numbers were correct, but the judgment? Missing. Real engineers don't just calculate, they think like detectives. Bridges, skyscrapers, dams, yes, we do those. But we also work on tiny homes, interior renovations, small retaining walls, solar panel frames, and even art installations. A former student of mine now designs structural frames for shipping container homes in rural communities. Lightweight, sustainable, and resilient. You don't need to work on a stadium to be a real structural engineer. Picture this. A lone engineer, hunched over a blueprint, calculator in hand, solving problems in isolation. That's the Hollywood version. The truth? Structural engineering is deeply collaborative. We work with architects, geotechnical engineers, mechanical teams, contractors, and clients, all in real time. I remember working on a hospital project. The HVAC ducts needed to pass through a beam zone. The architect didn't want bulkheads. The contractor wanted speed. We had to redesign the beam, move the column slightly, and still meet seismic code, all in 24 hours. Teamwork isn't optional, it's essential. Oh, this one makes me laugh. If you think solving real-world physics puzzles, ensuring public safety, and turning abstract forces into tangible, load-resisting structures is boring, you've never sat on a vibrating floor slab, wondering if it's resonance or just someone dancing. Structural engineering is dramatic. It's risky. It's invisible art made of steel, concrete, and time. Every structure you've ever walked in, driven over, or admired from afar, a structural engineer helped bring it to life. We don't crave the spotlight. We hold it up. So next time you see a bridge or a stadium or even a humble home, look a little closer. Beneath the surface is a story of calculations, constraints, courage, and an engineer who made it possible. We are structural engineers. We make the impossible stand. Don't forget to like, subscribe, and share this video with someone who still thinks we just draw beams. Let's rewrite the narrative together.